All right, we're looking at partial differentiation. And we've got this function here, f of xy, and we've got it written as x to the half plus y to the half plus 4. Now, here's some different notation. Okay, don't you love it in math? We got all this different notation. But I don't know, I find doing this notation a whole lot easier than that previous notation we just got through looking at with them funky looking backward looking sixes, but then partial signs. Remember those things, what we just got through working in the previous problems, we read those on the bottom from right to left. Well, guess what? We're going to be doing just the opposite. We're going to be reading this stuff from left to right. Anyway, so this right here took the place of all that other stuff. This is f with a subscript xx, which means we're taking two partials here, and both of them with respect to x. So we're going to be taking the derivative of this one first with respect to x, and then the partial with this respect to x. Okay, so let's do that. So here we go. I got the question mark, but we'll be able to figure that out here in just a minute. So the partial with respect to x. Now, we're going to be leaving, remember, because y is out here by itself, it's just a constant. See? So let's look at this one here. The derivative of x. So you take the half, bring it out front, right? So this should be old hat by now. X, subtracting 1 from the exponent, and a half minus 1 is negative a half. Now, the derivative of this with respect to x is going to be 0 because it's just a constant, and derivative of 4 is 0 also. Alright, so we want to rewrite this, taking x to negative a half down into the bottom, making it a positive half, and I guess you can do whatever you want with that and turn it into a radical. We kept it as exponential form up here, but anyway. We still need to take the derivative again with respect to x. Let's scroll down and see what I've done. Okay, well, if we're going to take the derivative of this again with respect to x, we don't need to rewrite it like this. Keep it written as such. So now what we're going to do is we're going to take this negative a half, bring it out front, times rewriting this coefficient and subtracting 1 from the negative half, which becomes negative 3 halves. Alright, now we can multiply. Let's see, simplify this thing down, get this into positive exponent form here. A half times a half is a fourth. Except I'm going to put that 4 down here in the denominator, bring the negative out front. Only 1 stays in the top, and because it's a negative 3 halves, we take that down into the denominator, and it becomes positive 3 halves. Alright, so we found that, and that's really not too bad. Let's scroll down and look at some more. I think we're going to be doing these in this order here, xy, yx, and yy, I believe. Okay, so let's look at the xy next. Okay, so we're doing the partial of x and y, partial of xy, however you want to read that. So we did the partial of x, that was the first one we did, right? So those two guys go to 0, and derivative of x to the half is this guy right here. Well, we've already done that. Now we want to take the derivative of this, okay, with respect to y. Well, there is no y's in here, and therefore the derivative of all this, because it's just a constant, derivative constant, is 0. So we're done. Alright, now let's take the derivative of y, the partial of yx, I guess you could say here. Okay, so the derivative of y. So that's going to be 0 because it's just a constant, and the 4 will be 0. And then we take the half, bring it out front, and subtract 1 from the half. And this is what you're left with right here. And so then what we're going to do is take the derivative now with respect to x. Well, because there aren't any x's appearing in here, we just consider this to be a constant, and therefore the derivative of constant is 0. Alright, take the derivative of yy. So the first one, that's going to be 0, 0. We take the half, bring it out front, subtracting a 1 from it, and there you go. Now we take the derivative of y again. So you take the negative a half, bring it out front, you have a half. Subtracting 1 from this, you get negative 3 halves. Okay, and of course we simplify this down, negative 1 over 4y to 3 halves. So this was exactly like when we did xx, right? The exact same thing. And the reason is because there's some symmetry going on in this problem. But that's it. That's the different type of notation.